Okay, I'm going to do a couple of examples here about vectors. I know that could be a little bit of a daunting topic to see for the first time. I'm going to do three examples. Hopefully, I may have to save one of them for another video, but I'm going to do a total of three examples. One of them simply with adding vectors and dot product. One with finding the angle between two vectors, and then I'm going to finish up with a magnitude and direction problem where we actually have to add two vectors together. So let's start with one that's relatively simple. It didn't come out so well on the PDF, so I had to kind of rewrite the vectors here. I have three vectors: a vector u, which is 2I minus j, a vector v, which is 3I plus j, and a vector w, which is I minus 4j. So just a quick refresher of what that means. So we have vector u, for example, 2 in the I direction, and then minus 1 in the j direction. So I have 2, 1, 2, and down 1. So that's going to be our vector u. Vector v is going to be 3I plus j, so like that, and so on. So that's the whole idea of vectors. So let's go ahead and we want to find u with the dot product of v plus w. Well, let's start with finding v plus w. That's easy enough because adding vectors when they're in this format is rather easy, because all you have to do is add the I components and the j components. So over here I have a 2 plus, I have a 2I, and it's a little hard to see. I have a 2I and a 3I. So what that's going to result in, I'm going to have, oh wait, I'm adding v plus w, never mind. 3I, so I have a 3I and a plus I. So a 3I and a 1I. That's going to result in a 4I. And j minus 4j. Well, actually, this really didn't come out. Sorry, I had to correct a mistake here. This should be I plus 4j. So let me just make that quick change here. Okay. Okay, so anyway, we're adding v plus w. So I have j plus 4j. So this is going to result in 5j. So adding vectors is fairly simple. Now, we want to find the dot product. So we want to find the dot product. I want to find 2I minus j, and I want to find the dot product of what we just found, 4I plus 5j. I said 5j. There we go. Alright, so there's two formulas you have in your book for finding dot products. I'm going to use the first one, which is simply to multiply the I numbers and then multiply the j numbers and add it together. So this is just going to equal 2 times 4 minus 1 times 5, and the dot product of these two vectors is 3. Alright, it's not as bad as it looks. Okay, let's look at another one here. Find the angle between 2I minus j and 3I plus 4j. Okay, let's draw this first. Because maybe not used to seeing vectors so much. So let's draw this out first. So I have 2I minus j. So 2 this way, 1 that way, more or less. That's U. And V3I, this is only going to be an approximation, plus 4J. So, roughly in that area. This is not to scale, but you know. Anyway, we're trying to find this angle here. Trying to find this angle. So here's U, and here's V. So it looks like we should get something somewhere between 60 and 90, somewhere in there, some 60, 90 degrees. Okay, so there's I mentioned there's another formula for dot product, and we're going to use a variation of that formula to find this angle. And so cosine of theta equals the dot product of VW over the magnitude of V times the magnitude of W. Okay, so let's first find the dot product. Well, we've done that. We have another way of finding that dot product, right? Multiply the I numbers and multiply the j numbers. So I have 2 times 3 minus 1 times 4. 6 minus 4, so I'm going to get 2. Now, find the magnitude of V. Well, let's see, magnitude of V, so that's, we have 2I and a minus j, so that's going to be 2 squared plus negative 1 squared, and that's going to wind up being square root of 5. Magnitude W, 3 squared plus 4 squared, which equals square root of 25, which is 5. So that's 5 square root 5. So we could even rationalize a denominator. I mean, we're going to plug this into a calculator anyway, so, but that's going to be 2 square root of 5, and so we have 5. This square root of 5 times square root of 5 is 5. Multiply that by 5 again, and we get 25. Okay, so that gives us this. Now the cosine of theta is equal to this number. So I can say that theta is equal to the inverse cosine of 2 square root of 5 over 25. And if you plug that into your calculator, you should get about 79, roughly 79.7 degrees. So this drawing really isn't to scale, but you can see this probably looks more closer to 70 or 60, but again, this drawing wasn't really to scale too much. Okay, I'm going to stop the video here because I don't think I'm going to have enough time for the third example, so we'll have to do that in a separate video.